Hi, I chose to review problem number 9. So it reads, express the GCD of each of these pairs of numbers as a linear combination of these integers by finding the Bezo coefficients of the numbers. The numbers are 117 and 213. So first I'm going to run through the Euclidean algorithm to find um, the linear factors as they get down towards 0. So first it's going to be 213 equals 117 times 1 plus 96. I'm going to take that as my new linear factor, find the coefficient of 1. So 117 equals 96 times 1 plus 21. So I'm going to bring down our original remainder there to show that 96 equals 4 times 21 equals 12, or 4 times 21 plus 12 equals 96. Then take the 21 down here, so 21 equals 1 times 12 plus 9. And finally get to 12 equals 9 times 1 plus 3. And here we have an even division into the first linear factor. So 9 equals 3 times 3 plus 0. Once we get here, we know that our GCD was the last remainder, which is 3. So after this, I'm going to start with this equation, 12 equals 9 times 1 plus 3, and begin to reverse them by taking what my remainder equals to equal the original value minus the uh, divisor or cofactor. So it's going to start with 3 equals 12 minus 1 times 9, bring that up and say 9 equals 21 minus 1 times 12. Take this number up, and 12 equals 96 minus 4 times 21. 21 equals 117 minus 96. And 96 equals 213 minus 1 times 117. So this is a really helpful form because now I have essentially what my remainders are equal to and different linear combinations of each one. And this is going to help me go down the list when I need to find out the Bezout coefficients, which are going to be essentially just a linear combination of all of these combined. So starting up here with the last remainder, which is also the GCD, we're going to say 3 equals 12 minus 1 times, well, that should have started with 9, but I think I skipped a step, but 21 minus 1 times 12, which is 9. So it'll take that equivalent and put it in there, and then I'll keep moving down. So 3 equals 2 times, after, I'm sorry, after distributing this negative 1, I'm going to have 2 factors of 12 and negative 1 factors of 1 times 21. So those are my first new coefficients. And 12 is actually going to be equal to 96 minus 4 times 21. So I'm going to put that in place for 12 there and say 2 times 96 minus 4 times 21 is minus 1 times 21 is also equal to 3. And from there, I'll be able to have 2 factors of 96 and 9. So it's 2 times negative 8 plus negative 1 essentially. So negative 9 times 21. And then next, I'm going to replace my 21 with the equation that I have over here. So it's going to be 2 times 96, which is just going to carry down, minus 9 times this equation, 117 minus 1 times 96. Distributing that all out and adding, I'll have 3 equals to negative 9 times 117 plus 11 times 96. And then finally, I'm going to bring one of my last equations up. So the 96 is equivalent to 213 minus 1 times 117, and that's going to go in this place of this 96 here. I'll have negative 9 times 117 plus 11 times 213 minus 1 times 117. After factoring out and distributing that, I'm going to be left with my final equation, which will also contain my Bezout coefficients. So 3 equals negative 20 times 117 plus 11 times 213. And notice that these are the original numbers. So that being in place there, that means that we have the coefficients that are going to give us this perfect remainder. So as a linear combination of negative 20 times 117 plus 11 times 213, we'll have the answer 3. So these are our final answer coefficients, 11 and negative 20. And thank you.